Hi, I'm Charlie Lee, and I wanted to talk about STEM education. Just a little introduction about myself. I teach chemistry, environmental science, and computer science at George Washington High School in Philadelphia. I'm interested in all sorts of learning activities, such as learning Japanese, learning how to write, exploring all sorts of board games, strategy games, and stuff like that, and really just enjoying lots of conversation about different shows, musics, and books. Gaining a lot of perspective into the things that I like to enjoy, right? And when I think about my path in becoming a teacher, I think my interests very closely align with that. I'm always, talking to students and really just, with that back and forth conversation, trying to figure out what kinds of perspectives I'm learning from, all sorts of different eyes, right? And get to learn what people have experienced, right? In many ways, I think the job of a scientist and the job of an English teacher, a writer, overlap in many fundamental ways. And when I think about what STEM is, I think about this core concept here around cultivating an idea, right? You have this idea that you want to, you know, really take a look at and be very careful and considerate about what this idea means. And oftentimes we do this through the lenses of logic and the beliefs we collect around us, right? The lenses of logic, right? We often use mathematics in order to analyze, different sets of data, like what do these numbers mean, et cetera, et cetera. We often make arguments to persuade other people that our idea is, something that seems good in practice. And the beliefs we collect around us, well, we are a product of a society which has many different beliefs, right? And oftentimes ideas um come from those beliefs, right? And so when we think about what STEM is, I think in its most general form, it's about gaining insight from the careful consideration, from the cultivation of an idea, right? And so when I think about the practices I do in my classroom, I think the biggest thing that I do and I have my students do is to ask questions, right? Ask lots and lots of questions, right? Because when you're asking questions, you're really thinking about, okay, so what do I want to learn about this idea, right? What kinds of limits exist on this idea? What kinds of implications does this idea have, right? When you think about ideas, well, you want to plan and carry out lots of investigations, right? You want to see, okay, well, if this idea does this, right? For example, if the vaccine is 95% effective, well, what kind of investigation was carried out in order to prove that, hey, it is 95% effective, right? Oftentimes we develop and use models, right? For example, when I'm teaching about the structure of an atom, well, the structure of an atom didn't really come out of thin air, right? It came from the building of many, many ideas across many different technologies, right? Oftentimes I ask students to um, figure out, okay, well, what are the limits of these ideas? What are the limits of these models, right? Um, and be very careful about how you apply the information that you're learning. And, I can think about so many of these different things, right? Last thing here, engaging in argument, right? How do you convey the ideas and the information that you learned to other people and have them believe what you believe, right? Engaging in argument, right? There's a lot of different things that um, really make up STEM, and all of these things here, I think, um, become very important when you're thinking about why STEM is important, right? It's a framework for tackling these ideas. It shapes how we approach these complex issues and make sense of them. So the goals I'm interested in, right? What are some different ways that we can cultivate and support students in learning STEM, right? Um, Cultivating this ability to reason with ideas, right? How can we undo the learned stigmas of STEM? Oftentimes I hear students saying, I'm bad at mathematics. How do we, you know, reframe that? How can we identify positive behaviors and attitudes towards STEM? And how can we reinforce scientific practices both in and out of the classroom? I hope to learn a lot. Thank you.